All right. So I have a couple of sample problems here that we are going to look at. So question number one, what is the standard heat of reaction for the combustion of solid glucose? All right. Please note water is produced as a gas. And the second question is how many kilojoules of heat would be produced if you combusted 304 grams of glucose under standard conditions. So that's what I'm going to be showing you. Hi, this sample problem video is to help students understand how to figure out heats of reaction for chemical reactions. And the first sample problem that we have is what is the standard heat of formation for the combustion of solid glucose? Now, obviously, we need to know that glucose's chemical formula is C6H12O6, and it's a solid. And we need to have to start off with a with a balanced chemical equation. So we have C6H12O6. And since it is combustion, that means it is going to react with gaseous O2. And it's going to form carbon dioxide, which is a gas, and also water vapor, which is also a gas. And we have to balance this chemical equation. So we go through and balance it. And to save time, I'm going to skip to the end of the balancing and have 6's on the oxygen, carbon dioxide, and water, and only 1 glucose. Now, the next thing we need to do is we're going to be using the formula for the standard heats of reaction that basically says that we take the sum of the products and subtract the sum of the reactants, their standard heats of formation. So that is, so heat of reaction is equal to the sum of the heats of formation for the products and subtract the sum of the heats of formation for the reactants. And N indicates that we have to take into account the number of moles involved, in other words, the coefficients. So for the reactants, we have carbon dioxide and water vapor. Now for carbon dioxide, using the standard enthalpy chart, we see that carbon dioxide, CO2, is negative 393.5 kilojoules per mole. So we're going to go and say, all right, for the reactants, for the products right here, my bad. For the products, we have 6 carbon dioxides. Each one, once again, is negative 393.5. And then we're going to add that, since it's the sum, we're going to add that to the waters. Now, water, when we look up gaseous water, you see that it is negative 286 kilojoules per mole. And since there are 6 moles, all right, because the coefficient is a 6, we put the negative 200 negative 286. So we have the 6 moles times the negative 286 for the water. And we're going to subtract that from the sum of the reactants. Okay? We do products minus reactants. Remember, this was for the CO2, this was for the water. And then for the products, with the reactants, we have 1 mole, so 1 times C6H12O6. And when we look that up, we see that for glucose, it's right here, and it's negative 1,275 kilojoules per mole. So negative 1,275. And we're going to add that to oxygen. But oxygen is a pure element. And when we look up the oxygen, we see that as a gas, it has 0 heat of formation. So that's going to be plus 0. And we go through and we do our math on our calculators. And we go, 6 times 393.5 negative. And we get equals, that's going to be negative 2361. And we add that to 6 times 286 negative. And we get negative 1716. And we're going to be subtracting negative 1275. So we have 2361 negative plus 1716 negative equals, all right, and then since that's 2 negatives, those are going to be plus, so we're just going to go plus 1275. And we equals a grand total of negative 2802. Right? Negative 2802. And I'm going to double check just to make sure. So we have 6 times 393.5 negative 236. And then we're going to add that to 6 times 286. And I see where I made a mistake. I was going, that's not the right answer. I made a mistake up here. And I'm actually kind of glad I did it. I did it on purpose. Yeah, that's it. If you notice, water, I used the liquid one, and that's 286. But this is gaseous water, it should be 242. So I'm going to go back here. I'm going to change that to 242, which changes this number. All right. And that should be 6 times 242 negative. And that's actually 1452. And when I add all that up together, it actually comes out to a grand total of negative 2538 kilojoules worth of heat being produced in this chemical reaction. Now, the fact that it is negative means that it is exothermic, which means that the heat is being produced. So if I were to rewrite the balanced chemical equation, since the heat is being produced or released, I could simply write it as another product. So I take the balanced chemical equation, I rewrite it, and then I add on the product side 2,538 kilojoules. Now, if that was a positive, that means it would be an endothermic reaction, which means that that heat would have been added over to the reactant side. But it's not, so it's not. Now, for part 2, it's asking how many kilojoules of heat would be produced by the combustion of 304 grams of glucose under standard conditions. So now I'm trying to find out the total amount of heat. Now, if you look at the balanced chemical equation, this is basically saying that we have 2,538 kilojoules of heat produced for every 1 mole of glucose being consumed. That's an important equality that we're going to use for our conversion. And basically, this is a chemical conversion problem. I have my starting point and end point. So I have my 304 grams of glucose. And the question is, how many kilojoules worth of heat are being produced? Well, to go directly between moles and kilojoules, I know that for every 1 mole of C6H12O6, it is going to equal 2,538 kilojoules. And I also know, since that is grams, I need to be able to get to from grams to moles. I need to have the molar mass of C6H12O6. And 1 mole of glucose is equal to 180.18 grams of glucose. And that's 6 carbons, 6 oxygens, and 12 hydrogens. So I set up my grid, 304 grams of glucose. I have 180.18 grams of glucose on the bottom, and that's equal to 1 mole of glucose. And then I have for every 1 mole of glucose, I have 2,538 kilojoules. Grams cancel with grams, moles with moles. I'm left with that number of kilojoules, which is exactly where I want to be. So I take 304, divide by 180.18 times 2,538, and I get as my answer 4.28 times 10 to the third kilojoules of heat being produced. I hope that you found this helpful. Good luck.